Okay, now you can see my big Tesla coil. Technically it's medium sized by the standard of Tesla coils nowadays. But I'm only 18, so this is the best I can do. Which, you know, I'm pretty proud of it. It's nice. My primary coil is a cone design. It's not flat, obviously. And I have a extremely crooked strike rail that actually works really well. So, you know, you can see the strike rail connects over there. And my primary, secondary, my toroid, which is made of aluminum ducting, and some pie tins from Marie Callender's. So, yeah. And it's got the same base as the small Tesla coil, same design. And we come over here and we see input power goes into that hole in the bottom left corner. And I have a safety breaker for over voltage, and also when I'm working on the coil I can flip that, and it'll never accidentally turn on. And not that I have any friends that would turn it on while I was working on it anyway. But I got my main ground that I connect with jumper cables to an earth ground that I've installed. On the other side of the ground are these three connections. One of them goes directly to the breaker, one of them goes to the ground of the transformer, and the other goes right there to the bottom of the thing that's not focusing. Right, yeah, there you go. That's the bottom of the secondary coil. And I've got a lot of zip ties in here, as you can see, holding this thing together. And so back to the transformer. This is 15 kilovolt at 30 milliamps. And I'm going to walk over to the other side now. Coming directly from the transformer, you can see that wire going down to the other side, and this one comes right down to here to my safety gap. And this one is set just a little bit bigger than my primary gap, and more, you know, Tesla coilers know exactly why, but I'll tell you anyway. That's so that if excess voltage ever goes awry, let's say if I get ambitious and a strike actually comes down and hits the primary coil and misses the strike coil for, you know, good old Murphy always trying to get it to hit the primary coil. If that should ever happen, the energy would first come and be choked down through the choke coils, so named, and they come down and eventually they hit the safety gap, which fires occasionally, but not actually intensely firing, just tiny little arcs. But it's nonetheless, my primary gap is firing like crazy all the time. And my primary gap is 6 copper end caps for copper piping mounted on acrylic. And I finally have my primary capacitor. Same process as the other one. It's a Tupperware container that's been fully sealed, airtight except for the hole in the top where the vacuum pump goes. Those two leads go directly up to the primary coil. There's my wire tap. And up to the spark gap right there. And coming from there are these two tiny pieces of magnet wire that lead back to the choke coils and back to the safety gap and back to the transformer. So this is my medium Tesla coil, and I'm getting, well, it's not the most efficient thing in the world, but it's actually really cool. You know, I have about an 8-inch gap right there. It's cool. It's cool. Well, maybe not that much. It's you know, I've widened it out before. I don't think I've ever gotten solid 8 inches. I've gotten crooked 8 inches, and the crooked 8 inches, of course, it comes over here and it kind of snakes around before it hits there. So you straighten it out, it'd be 8 inches. But I don't know. I haven't fired it up yet since it's been repaired. And a lot of this stuff is new. The primary capacitor is definitely new. So who knows? I could get a foot or more out of this thing. I really have no idea. Well, it's going to be fun. Next video will be the small Tesla coil working, and be followed eventually by the big Tesla coil working. Thanks for watching.